Okay, so we're going to specifically focus today on factoring by sum of cubes and difference of cubes, which you guys may or may not have seen when you were back in Algebra 1, but we're definitely going to go through it today. Difference of squares at the top of the page, you guys should have definitely seen when you were back in Algebra 1. So for sure, you should have seen that before. So I'm going to go through the difference of squares just to refresh your memory, and then we're going to move on to the actual Algebra 2 content for today. So the first part is difference of squares. So difference of squares is when you have two terms that are being added or subtracted, and the good thing is you'll be able to actually simplify this to a nice pretty rule. So if you have a squared minus b squared, you can rewrite this as a plus b and a minus b. How do you think we got the a and b? What did we do to the a squared and the b squared? We did separate them, but what else did we do? We can technically factor, so we could technically factor this if we wanted to, but I heard, Olivia, I think you said something? We can square root it. So technically to get from these answers to both of these, if you notice, they're not squared anymore. So the opposite of squaring is to square root. So I'm just going to make a note down here that you're just going to square root your a squared and your b squared terms. You're just square rooting both of those. So for question number 1, we are going to, and for all of these questions on this entire packet, we are going to factor completely. Hopefully I spelled that correctly. We are going to factor completely. If I asked you to factor completely, question number 1, Caitlin, the first thing I would ask you to do if you've tried to factor completely for question number 1, before you start square rooting, what should you look for first? Greatest common factor, the GCF. So I'm going to make this in a big, pretty green color at the top of the page. You would need to check for your GCF, which is your greatest common factor. And I'm going to highlight that so you don't forget it. Before you do anything, before you start solving or anything like that, I want you to check for a GCF, which is a greatest common factor. That could be a combination of numbers and variables, or it could just be numbers or variables. So before we do anything with the first 4 questions, look at all of them with the person next to you. Is there a GCF you can factor out first? If there's not, you're good. But if you can factor out a GCF, do that first. Just the first 4. Just the first 4, guys. The first question, could we factor out a GCF? Yes or no? No. Okay, so for question 2, could I factor out a GCF here? What? 2. So we can rewrite this as 2 parentheses. 72 divided by 2 is 36. C to the 4th minus 1. So that should be for question 2. We'll factor that further in just a second. For question 3, is there something we could factor out? Okay, just a 7? N and M. Okay, so I'm actually need more space, so I'm going to put this underneath it. You don't have to, but I will. So it's going to be 7MN. And what does that leave in parentheses, Hewan? What does that leave in parentheses? Perfect. That's exactly it. All right, for the next part, we're going to factor out for the 4. We can definitely factor out, if I'm not mistaken, a 10 and a W. So we're going to make this W to the 4th power minus 1. Okay, so that's the first step. For all of these sections, even though I'm not doing this whole page right now, you can always go back later to see which questions we need to factor out a GCF. So we'll do the next section in a bit. Okay, so still stuck in the first section, I'm going to look at the first question here, and it actually says for me to factor completely. So one part is looking for your GCF. The second part is to actually apply this rule to this question. So if I was to factor this, that means that your a squared is your 9x squared. That's what a squared is. Your b squared is 49y squared. Remember how we said that we are taking the square root of the a squared and the b squared? That's for both of these terms. We're taking the square root. If I was to attach the negative with the 49, what happens when you take the square root of a negative? It's imaginary. You can't simplify it. So that's why I'm not going to copy down that negative. We're just going to keep it as a positive 49. After we do that, guys, I'm pretty much just solving for the a squared and the b squared. I'm trying to isolate the a and b. So I'm going to square root a squared and square root the 9x squared. When you square root the 9x squared, Andrew, what is your answer going to turn into for a? 3x, good. And then do the same thing for b. If you were to square root both sides, what's the square root of 49? 7, and the square root of y squared? Just y. So this is going to be my answer. I have the a, I have the b, and I have the form that I want you to write it in, which is right next to it. So we're going to write this as 3x plus 7y and 3x minus 7y. This should be my answer. Andrew, how could I check to make sure that that's correct? What could I do? Multiply the two binomials, which will give you, hopefully, the 9x squared minus 49y squared. Guys, I'm not requiring you to check it as of right now, but if I put it on your test and quiz to show your check step, make sure you show it. It'll definitely help you with determining if you got the right answer or not. All right, let's look at question number 2. Okay, so for question number 2, we have this guy, and I need to see on the inside of your parentheses if I could factor this further. Okay, so for this question, your a squared is going to be 36c to the 4th. Your b squared is going to equal 1. Just like we did with Andrew, I'm going to need to isolate the a and the b. So we're going to square root both sides here. A is going to equal, correct me if I'm wrong, 6c to the 2nd power. And then when you square root b, b is going to equal 1. Give me some nods or shakes. Does this look okay? All right, awesome. So the last thing I'm going to do is just write my two binomials. So I'm going to write this as 6c squared plus 1, 6c squared minus 1. Is there anything I'm forgetting before I box that as my answer? The 2 that you have at the front. So don't forget to recopy that 2 that you factored out at the beginning. One thing that you guys are going to notice that we're going to do on further questions below, you always want to look at whatever's in your parentheses to see if you can simplify it further. Anytime it has an exponent other than 1, you want to double check. 6c squared plus 1. Okay, that's not really, I can't take the square root of 6. I could take the square root of 1, but I can't take the square root of 6, so I can't simplify that one. 6c squared minus 1, this is a specific difference of squares. It looks like it, but could you take the square root of 6? No, you can't take the square root of 6, so you can't simplify it. This would be your final answer. So right now with the person next to you, I'm going to give you guys about 3 minutes. I want you to simplify number 3 and number 4. Guys, the backs of your page are blank. I specifically made them blank so you could flip the paper over and show your work. These are your notes. You know what's best for your notes, so if you want to flip this over and use the back side, feel free. All right, so I flip my paper over because I know how I write, so I need more space. We're going to start with number 3, which means you need to simplify or factor the information that's in your parentheses. We already factored out a GCF, but we need to take it a step further. So you should have rewritten this as a squared is equal to m to the 6th power, and b squared is equal to 4n squared. Guys, keep in mind, the m to the 6th power, we're going to talk again about simplifying radicals, but you have simplified radicals in Algebra 1 and in geometry. So by going over it again in Algebra 2, it's kind of redundant. So if you wanted me to simplify, or excuse me, if you wanted to simplify the square root of m to the 6th power, that's the same as, I'm just kind of doing this over here to the side. The square root of m to the 6th power is 1, 2, 3, 4, 5, 6 m's. What's the index on this radical? A 2. There's a little 2 that sits on this little radical. So what this tells you is that you need to make a group of 2 of the same variable. So 1, 2, 3. I can make 3 groups. As I help each of those groups escape from this little radical prison they're in, how many 3s make it out? 3 total, but 1 from each group, right? Not all 6? Only 1 from each group makes it out. So the square root of m to the 6th power is just m to the 3rd. That's all. And that's for every single problem you have with multiple variables. So for instance, for this one here, you're square rooting both sides. What's the square root of 4? 2. And then the square root of n squared? 1 is just n, so just n to the first power. Guys, if you need to write this out for your variables that are excessive, if there's more than 2, you can do that. I don't mind. Okay, so let me write my answer for number 3. So this would be ideally written on the front side, but we're going to write this as 7mn parentheses m to the third power plus 2n, and then m to the third power minus 2n. This should be your answer. Give me a nod or shake. Is this okay? All right, for the next one. For this guy in the parentheses, you should have simplified. A squared is equal to w to the fourth. B squared is equal to 1. I'm going to square root. So for instance, for this one, w to the fourth power, if you have 4 w's, what happens when you simplify? How many do you have? W squared. And then the square root of 1? Just 1. So let me write this out. I'm going to have 10w parentheses, w squared plus 1, w squared minus 1. Let me ask you this. Are you done? Rua, what's wrong? What else can you still do? Why? What is it? It's another difference of squares. So you see how that w squared minus 1 is there? And you see how I wrote the directions on the front page saying factor completely? If you don't do this last step that Rua just said, you're not going to get full credit. Factor completely means you need to keep factoring until you can't factor anymore. I want to make a note here. Why can't I do the same thing for this one? Is this one a difference of squares? No. I'm going to make a little note here in pink. This is called a sum of squares. Sum of squares, guys, don't exist. So sum of squares does not exist. It makes no sense. If you try to find it mathematically, you'll get for sum of squares, it's something imaginary that you can find, but I never ask you guys for any imaginary answers for this. So when you are trying to simplify, guys, I just want the real solutions. So don't worry about simplifying this middle parentheses. So let me do the a squared is equal to w squared. B squared is equal to 1. I'm just simplifying this a little bit further. Well, if I simplify that further, that's going to give me w. And when I square root 1, I'll just get 1. So Rua, give me my final answer. I know I'm going to have the 10w parentheses w squared plus 1. What's the rest of it, though? Take a second to look at all of this, and I'll let some of you guys catch up. Can I do anything else to simplify this further? I'll give you a hint. These two parentheses I can't do anything with. This one I can definitely not do anything with. What did we say this was? Sum of squares. Sum of squares does not exist, at least not with the real solution. So for your simplified factored form, guys, this is what I want to see. Just this. If you get at least to this part, you're halfway there. I just need the other half. Give me some nods or shakes. Does this make sense? All right, perfect. And we're going to start looking at sum of squares, or excuse me, sum of cubes, because sum of squares doesn't exist. All right, sum of cubes. This is probably new for all of you guys. So let's just look at the cubes and the results. If you were to do 0 cubed, you would get 0. 1 cubed is 1. 5 cubed is 125. 8 cubed is 512, and so on. We can do that for all of the questions. If you think back to the questions that we have here, where it was asking us to square root, odds are we're probably going to have to cube root for this question. So what I want you to do next to this in the results space is I want you to actually write out what it would look like if you were to cube root, for instance, 0, which would just be 0. If you were to cube root 1, which should be 1, what's the cube root of 8? 2. You had to multiply 2 times 2 times 2 to get to 8. What if you cube root 27? 3. Write that for all of them. What would be your cube root if you were to actually cube root each of those questions? All right, so I have all of the items cube rooted. What we're going to do now is actually write out our rule. So here's our rule. It's going to be a little long in the sense that you have to remember it, but the good thing is once you remember it, you're perfect. You'll be great with it. So here's the rule. When you have a cubed plus b cubed, this is a sum of cubes, your factored form is going to look like this. A plus b times a squared minus ab plus b squared. Take a second and look at it, write it down. I have a lot of students at this point that are like, oh my gosh, Miss Tapia, you expect me to memorize all of this? Yeah, I don't have you guys memorize much, but I want you to memorize this. So there's a kind of an issue with this because honestly, the difference of cubes equation that I'm about to give you guys looks almost the exact same as this one. There's just one difference, and that's soap. Hopefully all of you guys use soap before you come into class. Yeah, I'm not joking. S-O-A-P. Hopefully you clean yourself before you come to class. When you're writing out your equation for your sum and difference of cubes, if you can remember SOAP, you won't forget it. Because if you're finding, for instance, a sum of cubes, you need to have the same sign as the one that you're looking at, opposite sign, which is opposite of positive, and then this last one is always positive. So if you can remember SOAP, guys, you can always remember what the signs are for this equation. So same, opposite, always positive, and it's always referring to what you're simplifying. The last thing that you're going to have to do before we actually do the questions below is you're going to need to take the cube root of a cubed and b cubed. That's how we're going to get our answers for this. So let's start with question number 1. Let's be honest, I know how I am, so I'm going to flip my paper over to do question 1, but you are more than welcome to stay on the front page. Just like we did on the last question before I actually do these problems, look at all of them. Take a second, look up at the board, all 4. Is there a GCF you can factor out from any of these 4? If so, factor it out on your paper now. So look at all 4 questions. Is there a GCF you can factor out? If so, write it out. All right, so this is what we should have gotten when we factored numbers 1 through 4. Like I said, I'm going to flip it over and I'm going to do questions 1 and 2 with you. So this one and this one, you guys are going to do 3 and 4. So let me flip it over to the back side of my page. This is for sum of cubes. And for the first question, this is x cubed plus 27. Okay, so the first things first. I need to take the cube root of a, and then I'll need to take the cube root of b, which is 27. Amiko, what's the cube root of x cubed? Just x. Amiko, this is a cubed. What's the cube root of 27? What kind of 3? Just 3. We can just write 3. What I'm going to use is the same formula from the front side of my page to actually write my answer. So I am recopying this formula, and I'm remembering SOAP to help me with the signs. So we're going to first have a plus b, which is x plus 3, because your sign is already positive, so you're going to keep it positive. For the next one, look up at the board, guys, to see what I'm writing out so you don't mess this up. We're doing a squared minus a times b plus, that one's always positive, b squared. Why do you think I put all those parentheses? So I don't mess up. I don't want to forget anything. And you'll see why on the next question. So I'm just going to go through each of these parentheses and clean them up. We're going to do x squared, which is just x squared. The 3 times x is going to be minus 3x. Whoops, didn't even close that. And then the 3 squared at the end. What's 3 squared? I was like, please don't tell me 6. This is your answer. Let me double check though. This is a trinomial. Can I factor this? Well, let's see. The worst that happens is we can't. Over here to the side, I'm actually going to see if I can factor this because I have a trinomial and your brain should be saying, wait, you might be able to factor this. So let's see. X squared minus 3x plus 9. If you aren't doing this on the back, guys, I would definitely flip the paper over so you have this. So I'm going to flip this over, or write out my x chart, and I'm going to start multiplying this out. A times c is 9. Your B value is -3. Sonia, what are the multiples for 9? 3 and 3, is there anything else? Not 1 and 1. 1 and 9, yeah. Is there any others? I don't want any fractions or decimals, so yeah, let's just use these. Sonia, if I was to multiply each of those, and I know they all multiply to 9, but will any of those ever add up to 3? No, there's no possible way. I could make both of these negative. It's not going to work. I could make one negative and one positive. It's not going to work. Same thing with 9. I can make them both negative. I can make one positive and the other negative. It will not work. So this cannot factor. I want you to see that. So when you go to your tests and quizzes, you don't have to show me that, hey, I tested this out to see if it factored, and it doesn't. So this answer that I boxed is correct. You cannot factor this any further. So I will say that again. On your tests and quizzes, do not try to factor this any further. You're done. I also said I would do question number 2. So question number 2, I'm going to recopy what we have from the other page. We factored out a 4, and we have 125a cubed plus 1. This is a sum of cubes. All right, let's see if I can factor. So in this parentheses, we're going to do a cubed, which is 125a cubed, and b cubed, which is 1. All I'm doing is just trying to isolate this a cubed on the far left. So I'm going to cube root. And for same thing for b cubed, I'm just going to cube root. Alec, what's the cube root of 125a cubed? Look on the front side. Cube root of 125 is there. 5. And then what's the cube root of a cubed? What do you mean 1? I need a variable. Cube root of a cubed. Just a. So 5a. And then for b cubed, isolating it, the cube root of 1 is just 1. So I'm going to use my brain, and I'm going to actually rewrite this. Don't forget about your GCF, guys. We're going to copy this down. So for my first binomial, I'm going to have 5a plus 1, because you're keeping the same sign. For the second one, this is where it gets creative. So look up at the board. We're going to do a squared minus ab plus b squared. Ewan, why did I probably write it out just like this? What do you think is going to happen with this 5a squared? What is it going to turn into? This is the same as, you don't have to write this, 5a squared. How would you simplify this? What's 5a times 5a? There's 90% of the time when students don't write this in parentheses, they write their answer as just 5 squared. What did they not square? The full a. So they didn't do the whole 5a squared. So when you're doing this, guys, make sure that you actually square the 5 and square the a. So you're going to have 4 times 5a plus 1. We're going to make this 25a squared. That's a 25a squared. The 5a times 1 is still just 5a. And then the 1 squared at the end is still just 1. The biggest mistake, guys, that I know somebody's not paying attention to, the most times you guys mess up is with anything that's a term like this where it has a coefficient and a variable. This would be your final answer. Wait a minute. Do I need to check to make sure this one doesn't factor? Oh, I'm so glad I asked this. Do I have to check to see if I need to factor this further? No, you don't. You already checked the first one. This is a rule for for sum of cubes. So on the front side of this page, I'm going to add this little note. This guy here cannot factor. So this guy here, that trinomial, cannot factor. And you can quote me on it. You can tell it to your pre-cal calculus teacher. I don't care. You cannot factor it. So right now, I want you guys to do numbers 3 and 4. I'm going to give you guys about 5 minutes since it's a little new. But I want you to do numbers 3 and 4 right now. All right, for question 3. Eugene, what did you get for question 3? M plus 6n is in Nancy. Go ahead. Okay. Just 6n? Just what happened to the n? Remember how you had 6n here? So you're multiplying this plus this. So 6m and n. So I'm going to put m, then n. And then what's the last thing? Just 36? Not quite. Remember how you had 6n here? You need to square all of this. So 6 squared is going to give you 36. What's n squared? N what? N squared. It needs to be squared. So you're taking that n and you're squaring it. So it just happens to be n squared when you square it. Let me ask you one last thing, Eugene. Can you factor this part here? No, you cannot factor it. So please don't try. That should be your answer, guys. This is a 6, M as in monkey, N as in Nancy. So make sure that you have that written out. All right, the last part, Melanie. I know I have a 3CD for question 4, so I'm going to rewrite this as 3CD. What should be your binomial at the front? Okay, and then go ahead and give me the first part. You should have taken the A part and squared it. So what did you get? Perfect. Wait, minus or plus? Minus the what? And then plus what? Perfect. That's it. This should be your answer. And remember, Melanie, one last question. Can you factor this part here? No, you cannot factor it, guys, so don't try. All right. So far, even though it took us a lot longer for this middle section, the next part should be easy because we're literally just taking this exact same formula that we have here, and we're just going to replace our signs using soap. Like I told you guys, use soap before you come to my class. All right, so down here at the bottom, for difference of squares, or excuse me, difference of cubes, we're going to write this as a cubed minus b cubed, and we're going to use the same outline. A, b, you're still going to have a squared, AB, and B squared. If you can remember soap, you should be good. So I'm going to remember for difference of cubes, we're going to keep the same opposite. And this last one, guys, is always positive every single time. If you can remember where the A's and B's go, which ones are squared, which ones aren't, you should be good as long as you can remember soap. The last part is the same thing that I wrote here for your cube root. It's still dealing with cubes, so we're still going to have to cube root some things. I'm going to make the same note. You're going to cube root the A cubed and your B cubed. So at the bottom, I'm going to do questions 1 and 2 with you guys. You guys are going to do questions, or excuse me, I'm going to do questions 1 and 3. You guys are going to do questions 2 and 4. So for question 1, I'm going to have to do the cube root, and notice that all of these are being subtracted. All right, before we do anything, look at all of the questions. Is there a number I could factor out? I have to check for a GCF. So look at the first question. Give me a nod or shake. Is there a GCF we could factor out here? Yes or no? No, there's not. What about number 2? I know the numbers are big. No, there's not. There's actually not. There's not. Besides a 1, it won't work. And then for number 3, can you factor something out? What can I factor out, Mia? Positive 4. So that's going to leave what in parentheses? 1 minus 8 h cubed. All right, sounds good. And then what about the last one, Mia? Can I factor this one too? What can I factor out? What's that going to leave in parentheses? X cubed minus 27 what? There you go. All right, perfect. So the good news is when you come back to this in a second, you'll have all of the things factored. So what we need to do now, I'm only going to factor with you questions 1 and 3. And I'm going to do it on the front side of the page because I think I ran out of space on the back. So for question number 1, let's start there. Everybody, we're going to do it together so you're all on the same page. In this, you have a cubed minus b cubed. So here's a cubed, which is x cubed. B cubed is equal to 1. If you have space on the back of your page, guys, feel free to use it. All right, so from here, I'm going to take the cube root. So A is going to equal X, and I'm going to take the cube root of B. B, the cube root there, is 1. Remember, we didn't factor out a GCF, so I don't need to worry about putting in a number in front of your answer. So here's going to be my final answer for x cubed minus 1. We're going to have A minus B, A squared plus AB plus B squared. I always put this in parentheses first to see what do I need to actually square, what's okay as it is. The x minus 1 in the front is fine. X squared is just x squared. X times 1 is just x. 1 squared is 1. This should be your answer. Quick question. Could I factor this? We didn't have much luck with the last question, but I don't know if we could actually factor this. So let's double check it. I'm going to make my little X chart over here to the side. I need to find two numbers that multiply to 1, but add up to 1. Michelle, what are the multiples for 1? And I know both of these will multiply to 1, but when you add them, will you ever get 1? No. So just like the last one, you cannot factor. So up here at the top, I'm going to make that as part of my notes. Up here, you cannot factor. Cannot factor. And that's going to be for every question you guys do. All right, so let's look at question number 3. And then after question 3, you guys are going to do questions 2 and 4. I'm not doing 2 and 4. You guys are. All right, so for question 3. All right, let me focus on the A cubed, which is 1. That's the first number. And then your B cubed is 8H cubed. All right, so let's see what our answer is going to be. I know I need to cube root each of these. All right, so let's see. The cube root of 1 is just 1. The cube root of 8, okay, let me look back at the top. Cube root of 8 is just 2. That's what I have at the top. So cube root of 8 is 2. And then the cube root of h cubed is just h. All right, so this is what I have to write in. I'm going to be careful first to make sure that I actually square the 2h correctly. So let's plug this in. We're going to have 4. A minus b, so we're going to have 1 minus 2h. I'm going to put the bigger parentheses underneath. We're going to have a squared, which is now 1 squared, minus a times b, which is 1 times 2h, plus, sorry, that was plus, not minus, plus, at the very end, b squared, which is 2h squared. All right, let's see what that bottom part's going to look like, that trinomial. 1 squared is just 1. 2 times h is positive 2h. Don't forget your signs. Make sure you're keeping track of them. And then 2h squared is going to turn into 4h squared. Be careful with those, guys. Be careful. So right now, I'm going to give you guys about 4 minutes, and I want you to do questions 2 and 4. So right now, do questions 2 and 4. So for questions 2 and 4, these should be your answers. Double check to make sure that your numbers and your representation matches like mine. I was talking with another student. I would just keep your answers when you plug them in. Keep them in the order in which you actually write them as your answer, as it has here. The reason why is if you start moving these variables or these terms around, it might mess up your answer. For the ones that are positive here, if you were to rewrite the 25 first and then the 36 and then the 30, it's not going to mess up your answer because all of these signs are positive. If you tried to do that for the questions that we just did above with the sum of cubes, where you have these that are being subtracted, it's going to mess up your answer if you just start rewriting these in crazy orders. Make your life simple, guys. Keep them exactly as you see it after you do SOAP. Just keep it the exact same. All right, let's look on the next page really quick. There's only a couple things that I want to talk about with you guys on this page, so listen carefully. The first statement at the top, these are like the common mistakes that you guys want to avoid, and these are the same mistakes I see pre-cal students making, so just be careful when you do this. First thing that you guys want to make sure that you do is that the sum of two cubes does factor. So sum of two cubes, which is this item here, that does factor. The sum of two squares does not. So remember how I said, I think it was on the back side of this page, this part here was the sum of squares. You could literally square root this, you can square root this, but the sum of squares does not exist. You cannot just factor that. So that's what that first statement says. The second one is when you have x cubed plus y cubed, you can't just rewrite it as x plus y cubed. You cannot write that. And then same thing here. X cubed minus y cubed is supposed to say, this should say, I'm going to cross this out, x minus y cubed. That's what it should say. These two do not match. You cannot write this nor this. Both of these do not make mathematical sense. So I'm not going to do all of the questions on this page. However, I'm going to do question 7. You guys are going to do question 4. All of the rest of these are up to you guys if you choose to do it a later time. For question 7, though, let's have some fun. I'm going to flip this over to the back side of the page because I'm going to need the space. So for question 7, we have x to the 8th power minus 10x to the 4th plus 9. At the very top of the last page, Caitlin told us at the very beginning, check for a GCF. Does this have a GCF? No. Most I can factor out is a 1. The issue is I don't know how to factor this. I don't know what else I'm supposed to do. I don't have any x squared. I can't just square root some things. So I need to figure out what to do. This isn't a difference of squares, nor a difference of cubes or sum of cubes. It's in the same form as a normal quadratic function or quadratic expression, ax squared plus bx plus c. So we're going to factor it just like you would, ax squared plus bx plus c. So I'm not going to graph, but I'm going to write out my little x chart to show you how I'm going to organize it. Your a and c are the 1 in front of the x to the 8th and the 9. So what's 1 times 9? And then your b value, which is negative 10, is going to go down here. Let me think. If I wanted to find two numbers that multiplied up to 9 but added up to 10, Olivia, what numbers could I use? Mm-hmm. Let's start simple. Give me the multiples for 9. Is there any group of those numbers that will add up to negative 10? So both of those are negative. This is a negative 9. This is a mistake numero uno that most of you guys have made on your last quiz that I want you guys to remember. When your leading coefficient is a positive 1 in front of your x squared, you can just write out both of your binomials. Unfortunately, for this one, this is x to the 8th power. So you can't just write out both of the binomials. What you have to do, and I'm going to write this out, you have to factor by grouping. I know you don't like it, but you have to do it. So down here for the x to the 8th power, I'm going to rewrite this as x to the 8th. Negative 10x to the 4th is the combination of negative 1 minus 9. So I'm going to make this negative 1x to the 4th power minus 9x to the 4th power. And if you're like, wait, Ms. Tapia, why are you putting x to the 4th power? If you add both of these, they should equal negative 10x to the 4th power. And then at the very end, I'm going to add 9. Victoria, what could I do from here if you're factoring by grouping? Okay, so in the first group, what can you factor out? Okay, you can factor out 4 x's. What does that leave in parentheses? Not quite. When you're multiplying variables like this, you're adding your exponents. So 4 plus what will give you 8? When you were to redistribute this, guys, when you're multiplying bases, you're adding your exponents. That's algebra 1. What else are you left with in here? Okay, good. In the second group, what can I factor out? Okay, what kind of 9? Negative. So let's factor out a negative 9. I always tell my students, whatever sign this first term is, let's factor out that sign. So a positive or negative 9, what's left in the parentheses? Not x squared. X to the power 4, and then what? Minus 1. Guys, both of these binomials have got to match. They have to match. I'm seeing too many quizzes where these things don't match and y'all still keep it. These have to match. So I'm going to write this as x to the fourth power minus 1, and then x to the fourth power minus 9. My question to you guys is, am I done? I'll give you a hint. You're not. You factored it, but you haven't factored it completely, which is what the directions say on the front side. Factor it completely. So, how could I factor this further? Say it again. I can't. It's already kind of been squared already. What is the only factoring we've talked about where I could do something with squares? Difference of squares. Are both of these being subtracted? That's a good sign. Could I square root both of those? All right, let's do it. So we're going to have a squared is equal to x to the fourth, b squared for this first binomial is equal to 1. In the second binomial, a squared is equal to x to the fourth power, b squared is equal to 9. I could do that for both of them. Okay, so let me square root. What's the square root of x to the fourth power? X squared. And the square root of 1 is just 1. We're following the rule, and I'm going to make this little note. This is difference of squares. That's why I'm able to simplify this further. No. No, it won't matter. You're still gonna have to simplify both of these, so it doesn't matter which one you have first. So Rua was just asking, if you have the x to the fourth power minus 9 here, and then x to the fourth power minus 1, does it make a difference? It won't make a difference. All right, so for the first one in blue, we're gonna have x squared plus 1, x squared minus 1. And then for the second one, I'm gonna square root all of these. A is gonna equal to x squared, b is gonna equal to 9. Oh, not 9. Square root of 9 is 3. So in my next binomial, we're going to have x squared plus 3, x squared minus 3. Am I done? Ooh, what else do I have to do? What's wrong? Why do I have to simplify this? Is this still a difference of squares? It is. Let me ask you this, though. Are the others? Can I simplify any of the other 3? This is a sum of squares that doesn't exist. And let me ask you this. The only one I might be able to simplify is x squared minus 3. Can you take the square root of 3? No. So these 3, let me cover them up with my fingers. These cannot be simplified. This middle one, though, you can simplify one more time. So underneath it, that's why I told you guys, use the back of your paper. A squared is equal to x squared. B squared is equal to 1. So let me rewrite what I have. I have x squared plus 1. I'm now going to have 2 more binomials. And then the last 2. So x squared plus 3, x squared minus 3. On your test, quizzes, and homework, guys, this is what's expected from you. So make sure you know how to simplify. Okay, so let me simplify. This is a square root for both of these. A is going to equal to x. B, when I square root, B is going to equal to 1. Plus 1, minus 1. This is your final answer. You don't have to simplify anything else because we've already talked about it. The x plus 1 squared, x plus 3 squared, and x minus 3 squared cannot be simplified any further. You're done. So right now, question number 8, I want you guys to solve it. It won't be as gross as this one, but check your final answer, guys. See if there's anything you can factor further. I'm going to give you guys about 4 minutes. Factor it. For question number, for question number 4 on the front side, question 4. I'm going to make a quick note on the front side of your page for question 7 that the work is on the back side of your page because I don't want you guys to forget that. But for question 4, you guys should have been able to solve this pretty quickly and pretty easily. So I'm going to make my little X chart. You should have found 2 numbers that multiplied to negative 125 but added up to negative 124. Maria, what 2 numbers multiply to negative 125 but add up to negative 124? So you should have rewritten all of this, factored by grouping. Maria, what did you get for that answer? So not for the final answer, but when you wrote the 2 binomials.
X to the power plus x to the power.
No, the one that has x cubed. Should have been x cubed plus 1, and then x cubed minus 125. That one?
Yes.
Okay, yeah, from there. Maria, after you did that, were you done? Did you just stop?
No.
What did you do from there?
You have to do difference of squares.
Not difference of squares.
For the first one, it's
Begins with a C. No. Sum of what?
Squares.
Sum of cubes. And then what is this one? Difference of cubes. So you should have used the sum of cubes and difference of cubes rule, guys. You can't use sum of squares and difference of squares all the time. Sum of squares doesn't even exist. So for this answer, your final answer should have been x plus 1, x minus 1, x squared minus 1x plus 1. And then for the second one, you should have had x minus 5, and then x squared plus 5x plus 25. This should have been your answer.